Okay, good afternoon everyone. My name is Rifqi Fikri. I'm a master student from Hwang National University and in the Department of Information and Communication Engineering. I'm from Indonesia and now I will present you about my research. The title is Ingredient Information Service of Meat-Based Korean Food Using Real-Time Object Detection. So this is the overview of today's presentation. The first one, the introduction of my system, and next is our architecture or the methodology of my system. Next is the challenging issues, and the last one is the conclusion. So introduction. Korean culture is one of the significant reasons for tourists to attract tourists to come to Korea, and then Korean food is also one of the biggest reason why the tourists want to travel to Korea. So based on this picture, we can say that if we travel to Korea and we experience a good Korean food, we will have a good experience. Our traveling will be more happy, we'll be more satisfied with our traveling if we can experience a good Korean food. So, but there's a problem, especially for foreigners like me. Let's say that how to order Korean food if I cannot speak Korean. And the second problem is how to read the menu to order Korean food if I cannot read Korean. And it can cause such problem, especially for people that has a restriction to eat certain kind of ingredients or meat, especially like Muslim or people who has Islamic religion. They have rules that prohibit them to eat pork meat, and from Hindu people, they also have restriction to eat beef meat because of their religion. So that's why here I propose a solution by taking a Korean food picture with our mobile phones. We can, and by taking the picture, and it will generate and classify the name of the Korean food that we take the picture of. And then after we get the Korean name or the name of the Korean food, and the application also will display the information, the detailed information based on the name of the Korean food. So this is the solution that I propose. Okay, next is the system. This is the basic configuration of my system. You can see here in the first step. For example, if we come into a restaurant or a market, let's say, and first thing, how the system works. This system will work. The first step is we take the picture or the videos of take video of the food, and then in the mobile application we install with an object detection system, and the object detection system will be classify the name of the Korean food. For example, here this is a picture of bosam, or you can say it's a pork intensis, and then the name of the food will be sent into the database with a web server, and then based on the database we will the system will show the detailed ingredient information by querying the name of the Korean food. So, for example, here bosam has and it shows the detailed ingredients like beef and the seasoning and maybe a garlic and etc. And as for the object detection flowchart, this is the flowchart. First thing is image acquisition, taking picture or the video. Next is for pre-processing like cropping, resizing, rescaling, and then next is the feature extraction with machine learning algorithm. Then we will training with object detection method. And object detection that I will use in this system is mini YOLO version 3, and I will explain it in the later slide. And the next step is if the food that we take picture of is already in the database or not. If it's yes, if it's a food name is already in the database, and the application will show the food name like this. But if the food name is not registered in the database, the user can have two options. First one, if they can try again to take the picture again, or else the user also can add some feedback feature. So user can take picture and add some information behind it, and user also can save the information into our database. So it's like crowdfunding. So with many feedbacks, our system will be larger and better and better. So it's okay. Next is here the system we train with 10 most popular meat-based Korean food. First one is a grilled pork belly. Next one is Korean style grilled sausage, Chinese cabbage wrapped pork, oxbone soup, beef stripes and intestines, chicken ginseng soup, glazed pig face, steamed dumpling, bulgogi, and marinated green beef short ribs. And these 10 data set, the class of data set are get from a Korean government website. And based on this one, I choose the 10 most popular dish. And next, for the data set, I also use reverse image searching with Python code to search and download the picture and the images based on the query searching. So I search grilled pork belly in the code, and then it will generate and download more than 200 of data sets. So every level here, I have 200 or more images for our training. So to recognize the Korean food, here we will use mini YOLO version 3. Mini YOLO version 3 is used a combination of a lightweight backbone and multi-scale feature pyramid network. The feature pyramid network means that the result here we have kind of like pyramids, like a feature map 1, feature map 2, feature map 3, and to extract. And then in the MS-VTN, multi-scale feature pyramid network, also in the mini YOLO version 3, consider of three main functions. First one, 3 main module. First one is the concat module. Concat module fuse the 3 feature map here of the backbone to generate the base feature. So it will generate the base feature. Also, it will also generate output for the encoder and decoder. Encoder and decoder generates group of multi-scale feature, and then it will send into the feature fusion. So it will fuse or aggregate 3 feature map base function and the result from the encoder and decoder, and then the result is feature pyramid. So it's kind of like a detailed version of each module. First one is concat module, as I already tell you. Concat module fuse feature from 3 different levels of backbone, which are crucial to constructing the final feature pyramid. And then the input of the concat module is 3 feature map, and in here we say a base feature for the backbone network. And then we also did here with upsample and to rescale the depth feature to the same scale before concatenating. So the upsampling is, and the result here is for the output for the encoder and decoder. And here in the encoder and decoder module, the result from the previous one, here the encoder and decoder will generate feature maps within the 3 scales. They build a thin U shape to construct encoder decoder. So based on the input from the concat module, it will go through the U shape module of encoder decoder and will generate 3 feature maps. Here we can say in the encoder, this is the encoder line. The encoder we have a convolution of 3 times 3, and then we also downsampling the feature maps. And then when it comes to the decoder, of course, we will upsampling, and here we also use a 3 times 3 convolution layer. Next, and the result is the sample, the generated sample will have a convolution of 1 by 1, and we use batch normalization and value to get the 3 scale results. Next is the feature fusion model. The feature fusion model this we can say is just like combining the result of the encoder decoder and the concat module, and the result will generate into our feature pyramid like here. We have three, the prediction in the feature pyramid here we have three, prediction set 1, set 2, and the set 3. Okay, and next, if we finish to train and to use the object detection, how can we implement the object detection to mobile application? So here we use an OpenCV for Android. OpenCV is open source of computer vision library. So the function is to helping the users to build a machine learning or computer vision program or products, and they also provide us an OpenCV for Android, and it's a kind of SDK, software development kit, with a set of samples and Java documentation and Java API also. So it's like kind of like API. So we just like put the Python code into the OpenCV, and the OpenCV itself we will kind of build an SDK and we can put it in our mobile application. So in the Android Studio, here is Android Studio, we can just put a library of the object detection into our Android Studio. Next, challenges and issues for this implementation. First one, for the food detection, the main problem to correctly detecting food item is the fast interclass variability of the food items. Since food items are handmade, they differ in shape, texture, size, even if it's present in the same food instance. As for the example here, in this picture, it's the same food, same name, but they have different seasoning. First one maybe has a spicy seasoning, and the other is like normal one. It can create some difficulty to the detection because it's different, right? Another problem in food detection is occlusion, especially for food item in a complex meal. The issue with complex meal is with including chopping, mixing, or ferrying food items with other food items. Yeah, it can cause it more challenging, like this picture. These two pictures is the same food but has a different kind of serving, right? Next one is object detection on mobile application. As you know, mobile application is obviously limited, more limited rather than a computer environment, and that's why to make an application for user, we want to make the application can make the user satisfied with the application features, right? So there are three main parameters that are important to run the image processing application in the mobile devices. First one is power measurement. Power measurement will determine the battery consumption each of the live implementation. Of course, user wants the application not drain the batteries too much, right? Next one is the time efficiency. Time efficiency measurement will determine how much fast and reliable the data transmission. Because here, the system use like kind database system, like we have to take a picture and send a query to the database and retrieve the query to the mobile application back, right? So time efficiency with time response is very important in this system. Next one is accuracy of the technology. So it will determine how good the performance for the object detection. Obviously, the application must be almost perfect for the object detection, because if we detect food wrong, it can cause problems, right? Okay, so the conclusion of this system, food ingredients are important, especially for people who have restriction to eat certain kind of food or ingredients or meat, like I explained before. Also, maybe some people have some allergies for certain kind of ingredients that are also important. So in this research, we propose a mobile application for food image recognition that can classify the name and the ingredients. And here we use 10 most popular meat Korean dishes. And here we also want to simulate and evaluate real-time image recognition with limited computing powers and resources such as mobile phone. Because actually, I think there are not many much image recognition system in the mobile phones nowadays, and for the future also we can broaden our system not only for meat-based Korean dishes. We can also, for example, for the Korean street food, or maybe the other ingredients might be in the farm also, like this is what kind of vegetable, this is what this kind of fruit is this, so it can be much improved. Okay, I think that's all for my presentation here. Thank you.